Okay, I'll start first. Okay, SN2 mechanism, okay, basically tells you on the concept that, right, it will attack via the backside attack, right? So therefore, it will attack at the electron deficient carbon that's less steric hindrance. Okay, so that's the first thing that you have to know of first. So if you look at, for example, this given example, right, okay, now, between carbon 1 and carbon 2, which I label as 1 and 2, right? Okay, carbon 2 definitely has experienced less steric hindrance because it's less substituted with carbon chain, right? Here got, 2 adjacent carbon, here only have 1 adjacent carbon. So since it preferred undergo SN2, so my nucleophile, which you identify as I- supposed to attack here, and then you break at here, things like that. So that's how we got the product as shown. Okay, so this is like a pattern you're supposed to observe who is lost, just like this given example. Okay, sure. Sonia, okay for you? Lashita? And anything else me? No. Okay. So bearing this in mind, right? Okay, then we look at this one here. Okay. So we look at the top one first. Carbon 1, carbon 2. Carbon 1 is less substituted, right? Okay, that means it's has less steric hindrance. So your I- should be attacking at this carbon 1 here, causing this CO bond to break. So therefore, it will open in this way. So ultimately, after that, we'll have the H there, okay? At the bottom over here, C1 here, C2 here, C1 definitely it will be the one that's less steric hindrance. Okay, so that's why you will break at this bond here. Okay, so end up you will have this. So when you open up. Okay, so the I here, when you open up over here, this is the OH here, you open up the I over here. That's all. Is it okay? Yeah. I like this question because it's not so straightforward. You really have to understand the mechanism because SN2 basically backside attack. So you have to attack the carbon that has a less steric hindrance.
I just looked at which one had which one had 2 and then which one had 1.
This is actually the thought process, okay? Yeah. Because all of them should have 2. Maybe this is wrong because 2 moles, so it can be B or C what? It can be B, C, or D what? A confirm will be out because if you do by A, you realize that you only result in reacting with only 1 HI, right? But here is 2 moles of HI. So is it B, C, or D what? How
I mean, I just copy. You see where the O is directly bonded to your ring. Compared to it being the I being to a branch of C.
But that you happen to get correct, but the process is incorrect. Okay?
What does the O stay with the carbon asterisk?
The O don't stay on this one it get broken, right?
For the example, not stays with C1.
Because you break here. This nucleophile attack this carbon, right? So you break in this way. This one attack here, you break here. Yeah. Correct? Okay? Goes. I see. Which one you wrong? Which one you don't understand? The rest of you please sit down what you need. The breaking thing. Okay. Yeah. Very simple. If you look at your mechanism here. Alright, backside here, right? Okay. If I attack this one here, I'll break in this way, right? Something like that, right? Okay. So you break at the adjacent one. So if I attack here, I break here. Am I right? Correct? You look at your mechanism for SN2. If I attack here, I break here. Can see? So you're looking at the trend here. If I attack here, I break here, right? Yeah? If I attack this carbon, I break here, right? Because this CO is electron, how to say, there's it is polar. I will not break CC bond, right? Okay.
Okay, but how do you know if you break at the one or the other one?
You compare which carbon is less in steric hindrance because SN2 go by backside attack, so the carbon itself have to be less steric hindrance. You understand? Because you have backside attack. Okay, if it's SN1, then your nucleophile will attack at the carbon that is more substituted. So that is the origin behind SN1, SN2. Okay? Please take this down. SN1, SN2 meaning the nucleophile have to attack at the carbon that has less steric hindrance. Depends, because usually last year when you all go for your school tutorial for physical, right, even if you don't do, right, you can still follow. But I think for organic, right, make an effort to do. Otherwise, you all were totally lost in your school tutorial during your class session. Because tutorial, I don't think having a large class, right, I don't think they will like individually address each of the individual issue. But for now, I can address, but not in school. Yeah, so I don't think you want to waste 1 hour, sit down there, don't know, catch no balls, right? So make an attempt to do, especially organic tutorial. The rest, I leave it to you. You want to do okay lah, but organic you must do. Is it okay? Organic 会的一定要做 must do. Okay? Okay, I move on. But you still don't know, I later I come to you again.